look at the identity part and take a look at some of the other authentication methods. Okay. Let's log in here. First thing is we'll change it for the FMC itself. Okay, right here under the management interfaces. So the DNS is at 100.50. We'll change this here. And we'll remove secondary. You can add up till 3 DNS servers. We're gonna just keep it at one of them. In production, you would want to have redundancy, so you can have multiple of those. Save that. Okay. Next is we'll come into our firewall. We'll change it on the DHCP. So I'll add a new one. It's going to be, okay, just create an object for that. Remove this. Okay. Next thing we'll do is we'll also change it on the platform settings. So let's just check our platform settings. DNS. We have a DNS group. Okay. And let's just check what's in that group there. Okay, so it has a couple of DNS servers. We're going to change it from here. Save. That's really it. There was nothing else in the platform settings that we really have to change as far as DNS is concerned. Now, we also need to make a couple of other changes for DNS. One is we have an access policy, which is currently allowing DNS, but it's pointing to that open DNS. So we'll have to make that change so that the traffic is allowed for the DNS. We also would want these users to be able to, so these would be in VLAN 110. Okay, and our server is in VLAN 100. So this traffic will flow through our firewall. Okay, so we would need to allow these guys obviously to be able to access the DNS server. Okay, so we'll add those couple of changes as well. Let's come into our policy. Okay, so one is this one, primarily, which we need to change. And we'll remove these, and we'll add the HQDNS to our destination. And we'll keep it as trust, obviously. Okay. And I'll remove this one. This was just for testing packet tracer. Okay. So I'll remove that. And what else? Let me just edit this one as well. We might need search engine for a couple of testing later on, so I'll remove that from the category here. We already tested the URL filtering part, so we'll remove that. Okay, save. Okay, deploy this. Okay, while that's gets deployed, we're going to do certificate part. So what we did use for the SL decryption was we created a self-signed certificate. This is what we are using, right? But now we wanted to get it signed from our CA. Okay, so let me open up our CA, and we're going to access the FMC from here so that we can copy the contents and everything. Only one person can log in at a time to the admin. So since I already have a session, it asks me to end the existing session before it allows me to open the new one. Okay, so let's come into objects. PKI, I'm going to internal CA. We are going to generate a CA. Give it a name. The subject. Let's just name it this way. Okay, common name, I'm going to say okay. Now, previously we did a generate self-signed CA. Now we want to generate a CSR, a certificate signing request. Okay, so this is our request. Here's our subject at the top. I'm going to copy this, and we're going to go. We're going to open our certificate authority. Okay, it's available at certserv. So that's the URL. If you are running it on Windows server, okay, so you put in the IP address. I'm on the Windows server itself, so I'm just putting in localhost, and then this is the path, certserv. Okay, so that's our certificate services. That's our CA. We're going to request a certificate, advanced certificate request, and we're going to paste that certificate request that we copied from Firepower. Okay. I typically don't like to leave any blank lines. Okay, so I just do a backspace, which removes any blanks. I'll use the web server certificate template, submit, and we're going to change this to base 64 and download the certificate. Okay, so that's our certificate. Let's open that out, and we can see what the certificate is. Issued to, that's the name for which we actually generated the certificate. We can see all the details, version, serial number for the certificate. That's our CA, which is this subject. That's what we filled when we generated the CSR. Public key, key usage, etc. Okay, so this is our certificate. What I'll do, I'll rename that as well. And we're going to say FTD CA signed. Okay. Now, in addition to this, I also need my CA's root certificate. Okay, I also want my CA's root certificate. So we go back in here and I'm going to download CA certificate. Base 64, download CA certificate. Okay, so this is going to be my root CA. Okay, so I need to have that trust chain present. If I open this, the issue field, the issued to and issued by are the same. Okay. And in this is the identity for the firewall, and issued by, that's our C. Okay. Let's come back into our Firepower. And what we'll do first thing is we're going to first add the root CA certificate. So if you come down into trusted CAs, store. Okay, so there are already a lot of well-known CAs that are present, just like I showed you with the browser yesterday. Okay, so a lot of common ones, public CAs, they're already present. So the firewall already trusts, or the Firepower already trusts certificates that have been signed by any of these CAs. They're public CAs. Since we are using an enterprise CA and internal CA, the firewall, as of yet, will not trust any certificates that are signed by that certificate authority. Okay, so we're going to add that trusted CA certificate. Let's say Secure Lab CA, browse, and we're going to select that certificate that we done. It's going to load the content, and okay. Okay, we can search for that just to make sure that it was added. Okay, that's the common name, issuer, validity, etc. Now we can add the certificate that we issued. So coming back into internal CA, we'll open this CSR. And against this CSR, we'll have an install certificate option here. Click on that. Select that. Save. Okay. And hit OK. Right, so now we have this CSIN certificate that can now be used for our SL decryption. Okay, so let's use that within our policy. That's our SL policy. We're going to come in here. And here, we're going to select our FTDC assigned. Okay, check that, save, and save it again. Okay, now from testing perspective, obviously, we also need to have that root CA certificate in the trust store on all of our users, our end clients, PCs, browsers, etc. Okay, in production, you're going to be pushing this out through something like GPO, okay, or other centralized management perspective. Okay, you're not going to log into every PC and have the users install it manually. Okay, if the users are part of the domain, when they join the domain, the certificates, they can be enrolled into the certificates through GPU again. Okay, so you would need to have both of these certificates present in the trust store on the users. Okay, obviously we're not doing system administration and everything, so I'm not going to go into the GPU perspective and everything. Okay, so very simple thing that we'll do in the lab. I'm going to remote into one of the users. Okay, obviously not to something not you would do in production, but for our case, just in a lab perspective, I want to push these certificates out to the user, this guy here, for which we are testing. Okay, it's right here. So we're gonna remote in RDP in to him, okay, so that we can access that. Okay. Now, again, we would be RDPing into it. The traffic will flow through a firewall. The firewall needs to allow the RDP traffic. Okay, since we are going from VLAN to other, it is passing through the switch, and it'll go through the FTD from the management perspective all the way up to there. Okay, so from the management network here, traffic is going to come into this router because it's going a router on a stick. Okay, and then it's going to flow back through the firewall. Okay, so this firewall will need to allow TCP 3389 traffic from the outside to inside. Okay, so we'll first enable that on the user here, and then we'll add that to the, or let's first add it because it'll take time for it to get deployed, and then we'll make the change on the end device. So let me come in here. Let's go into our policy. Okay, so what we'll do is we'll add, I'm going to say allow RDP. Okay, and this time traffic is going to originate on the outside and it will flow to inside. Okay, I can add the source, so it will be coming in through, let's say 192.168.100.50. Okay, and it will flow to our LAN network, be the destination. Port is going to be TCP 3389. That's RDP's port number. And I'll enable the logging just in case it does not work and we need to troubleshoot and see what's going on. Okay. Move this to the top here. Okay, and once we have the certificate and everything done, we're going to remove it. Okay, so that we don't have this in our policy. Okay, it's traffic from outside to inside. That'll be the destination. The destination port is going to be 3389. Okay, save that. Push the deployment. Okay, so while that gets deployed, we'll, not really sure, it must be enabled here, but we'll just check still. Allow remote access. That's enabled. Okay, we should have it. It's allowed. And the user is HQ-user. Okay, cool. So let this finish and then we'll initiate an RDP to that PC so that we can copy out the certificate. 192.168, no. 10.0.110.101. It's going to be the IP address for this user here, which we're trying to RDP into. Okay, let's try it out, see if we are able to RDP into it. One, we renew the IP address. We changed the DNS on it as well. So let's just renew that. Let's just check the DNS. We now have the correct DNS here. Okay. Let's come back in here. Let's test. Let's check our events. And I don't see any RDP traffic coming in. So it might not allow it to happen this way. I'll explain why. So we don't see any traffic coming in from the outside. Okay, we do see the DNS traffic and everything working from here. And I think it might be because what happens is with firewalls typically, so on the firewall right now, this is the external interface here outside, which has an IP address of 4088.200.1. This is our LAN here, which is 10.0.110.101. Okay, and supposedly we're trying to do RDP from here. Okay. Now, when we're trying to send traffic, our destination is 10.0.110.101. This IP address is not part of the subnet on this network, the outside network, right? So typically firewalls have anti-IP spoofing, which basically says to not allow a packet having an IP address of a subnet which is not present on one of those connected interfaces. And this specifically is applicable on the outside because this is the part that connects to the untrusted network. So you don't want the firewall to, what is happening in this case, to allow anything to come in. You know, so right now, from the firewall's perspective, the LAN network is here. Okay, so we typically should not be receiving any traffic for this LAN network on the outside interface. Okay, I believe that's what's happening, and we can check that through packet tracer, just in case. Okay, so we'll do packet tracer and input, and we are receiving traffic on the WAN outside interface. Okay, it is TCP. Source can be anything. Let's just take the correct source. So in this case, it is 192.168.100.50. Okay, source port can be anything. Destination is 10.0.1.1.10.101, and it is 3389 destination port. And we'll do a trace for this as well. That's fine. Okay, so let's just check what it has to say. So we can see there's a flow denied, and we are not seeing this traffic in the events. Okay, so what I am looking for is, if this is working, I'm looking for an RPF check. Okay, so this should be getting blocked through reverse path forwarding. And this is not a Cisco concept. Okay, this will apply to any vendor device out there. There's an RFC for this, reverse path forwarding. Okay, so that's what we're trying to check here. Okay, so we have this rule here that it basically sees. Okay, so from access list perspective, it is allowed. Traffic coming from the outside going to inside, that's the port. So that's a rule that we created. And since it's an allow action, it basically says that the packet will be sent to SNOT for processing. And if you come down here, we should see an RPF check. And the result is a drop. Okay, so that's kind of like an already existing anti-IP spoofing that is happening here. Okay, and this is really a good way to test this. You're not going to see this in the logs. And when I say in the logs, you won't see it in the FMC logs, okay? Because it's not even reaching that part where it can throw the events into the FMC, okay? So that's what's really happening. So we have two ways to do it. Either we have an IP address which is in this subnet. So either what we can do is we can do a NAT, a static NAT, okay, which basically says, so if traffic comes in for, let's say 200.101, translate this, and this will be a destination NAT. Translate this to 10.0.1.1.10.101. We either do that, okay, or in our case, what I'll do is we'll initiate the RDP from the inside to the outside. Okay, so we'll initiate the RDP from this guy to the server. All we have to do is we have to just copy the certificate, okay? But good thing that we did it this way so that I was able to show you the RPF check here. This is a very common thing, okay? This will also come into play if you have configured a NATing incorrectly, okay? Because if the NATing is not working, it sometimes gets failed through the RPF, okay? So let's change that a little bit. So what we'll do instead is we are going to edit this. I'm going to say inside to outside, just reverse it. Okay, destination, I can put in the object. We already created one for HQDNS. Same IP address, 100.500. Port remains the same. Save that. Okay. Push the deployment. Let's give it a couple of minutes, and then we'll RDP from here. This says the username on my domain controller. So once you add it as part of, or you promote it as a domain controller, you add the domain services. It really substitutes whatever the domain name is. So in our case, it's secure.lab that we have been using, and then the username for the device. Okay. Okay. Let's see. So it works in this direction, obviously. That's our certificate for the PC that gets presented. And we are logged in here. So what we do need to do is copy these certificates to our PC. That's why I shared the drives. So HQ user, desktop, I'll copy those certificates to the desktop. So downloads, those are certificates. And place these on the desktop. Okay. Great. So we should now have these certificates on our user. We can go ahead and we can install these. So first do the root CA. Install current user. We're going to place it in the trusted root CA store. Next and finish. Import successful. It should do it for the local machine as well, but I kind of like to do it for both. Okay. Okay, here. Next. Next and successful. So that's done. Do the same thing for the FTD CA here. Install certificate. Root CA. Next and finish. And sometimes you get a security warning as well. And it says you're about to install the certificate. This is the identity for the certificate. This is the SHA-1 hash value. Yes, I want to install. Okay, and then I'll do the same thing for, so once we have done that for the user, it already does it for the machine as well. So you might not see that same warning again because it has already imported it. Okay, so we're good with that. Now we can go ahead and test our website. Okay, just and see the interception would still be done, but now the user should not see any non-secure connections. Okay. Let me just check the policies once. So we should even be able to do Google now or any search engine because we removed it from the URL here. Okay. But we could do YouTube or any other social media as well. So let's test it with that. Let's do, okay, so there are no errors. If we look at the connection is secure. If we look at the certificate, we can see now the certificate is the actual certificate that was signed or that we generated for the root CA or from our enterprise CA. Okay, but no errors since our user or the browser here is not trusting that certificate. If we come into our events here, we should be able to see our decrypt resign for Facebook. Okay, so decryption is happening absolutely correctly. It's able to put it into the category as well as show us the reputation. All right, so that's how you can do either self-sign or you can do it through a CA sign. Obviously, CA sign is a much more secure, is a much more valid way of doing these things in production. Okay, so that is your SSL decryption or TLS decryption, whatever you might want to call it. Okay, any questions? Okay. In continuation from this, because we'll be doing some more certificates, and I'll show you a different way in which you will have to do the certificate for this. We're going to talk about identity policy. Okay, so identity policy it's really related to how you can control the traffic and access based on users, or how you can control your users. Okay, so you could categorize this as being user awareness. We already looked at application awareness, application visibility and control, where the firewall knows about the applications and everything, okay, is able to reduce those. Now we put them, or we give it user awareness, okay. So for this, what happens is FMC, on the FMC, you basically create a realm. And within this realm, you configure your Active Directory. And then once that integration happens, you can download your users and groups. And then once you have these, you can then use these within your access control policy, or you can use it within identity policy. Okay, so maybe you want to give different types of access to people who are, or users who are part of maybe the IT group versus sales group versus HR, etc. You can control that one. Okay. Through the identity policy, however, you have the option of, again, controlling users. Okay. So there are two ways to do this. You have active authentication. And you have passive authentication. Active authentication is done something called as captive portal. Okay, so for example, if you have user here, this is my firewall and connected to the ISP. This user sends traffic. Okay, we have an identity policy configured which says captive portal. So what this happens is this traffic is redirected for portal basically. Okay, so it's HTTPS. And by default, this happens over port 885. You can change the port. Okay, so it's redirected to on the FTD itself. And the user is then asked to put in a username password. Which is then, consulted through the Active Directory. It's passed that username, password, and all the details within the Active Directory, email, phone number, etc., etc. Everything is captured within the FMC, and then the user is allowed to go through. Okay, that's active authentication. The user is actively asked to enter the username and password in real time. The user is aware about this. Okay. Now, obviously, since this is a secure portal, when this redirect happens, the user might or might not get, again, that non-secure error. Okay, so the certificate that we created, that won't be used for captive portal. For captive portal, you need to have a different certificate. Okay, so you basically need to have a web certificate. And from the perspective of the FMC, we were able to generate a CSR, okay, from within the FMC. For the captive portal, we won't be able to use the FMC. We have to use an additional piece of, I would say, software through which we are going to generate a private key, CSR. We're going to get this signed by a CA, just like we did. And then we're going to import this certificate and the private key into Firepower. Okay, and for this, we'll use OpenSSL. So if you have never used OpenSSL, you'll get a chance to see how it kind of works, because it is a CLI only kind of a thing. And there are lots of products out there which do not allow you to generate or do the CSR from within their product itself. Okay, so you have to use something like OpenSSL to do the work. Okay, so for this part, we're going to be using OpenSSL to basically get a web certificate done, which will be used for captive portal. So when this user is redirected, okay, there'll be a new TLS connection that will get established to whatever the IP address of the FTD is against this 885 port. Okay, so this user would need to trust the certificate that the FTD is presenting, otherwise they'll get a non-secure connection error, which from user's perspective, again, you do want to keep everything as transparent as possible in production. Okay, and this is also how you would do certificate for maybe something like when you would do decryption for inbound traffic. Okay, so I told you when you do it for the decrypt known key, you would be importing the private key from your web servers, importing them into the Firepower. Okay, so it's the same concept. The way that you do the certificate. Okay, there's nothing more to do apart from the SL policy that we have already done, except for using that different action. Instead of decrypt resign, using decrypt known key, the main part is to importing the private key. Okay, so we'll be able to see that. That's your active authentication, captive portal. Okay. The other thing here is passive authentication, which is done through ISE, Identity Services Engine. Okay, so it is Cisco's implementation of AAA. It is, you can call it a next generation network access control system. Okay, we'll be going over in very detail later on in the course, so I won't go into too much detail about it right now, but you can integrate FMC with ISE, and this is done through PX Grid. Okay, Platform Grid or Platform Exchange Grid. Okay, ISE is also integrated to your Active Directory. So anytime a user logs in to the Active Directory, okay, the details about this login is shared with ISE. Okay, and this is done over WMI. Okay, ISE has information. ISE publishes that information over to FMC over PX Grid. So passively or transparently, the FMC captures all the information about the users who are logging into the domain. IP address, username, host name, phone numbers, any details that the Active Directory had to offer. Okay, so this is passive. This is active. Okay, so in this case, all the user is doing, he's just logging in once to Active Directory, and all the information is basically pushed down to FMC through the ISE. Okay. In this case, the user is actively asked to provide the credentials to capture those values. If good, they're basically allowed to go through. And the information is captured. So that's the difference between the two. Okay, that's passive. In the earlier versions of Firepower, we used to get a Firepower agent as well, okay, which was a small piece of software which you used to install on a Windows PC or a Windows server. And it kind of used to work the same way, but it has been deprecated. So now the only thing that you have from the perspective of passive authentication is ISE. So if you have a Cisco suite of product deployment, then the integration is very seamless, and very tight integration can be offered against different products. Okay, so ISE alone does integrate with a lot of different products. Your Firepower, it integrates with the endpoint malware protection solution. It does integrate with something like WSA as well. Okay, so there's very tight integration for the complete portfolio. Okay, so obviously won't go into the passive bit. We'll discuss PX Grid when we talk about ISE. Okay. For now, we're going to keep our concentration on the captive portal or the active authentication. Okay, but this is there as well. Okay. So now the first thing that we will do is we'll integrate Active Directory first, import our users and everything, and then we'll go into the certificate. Okay. So let me just come in here to my, we'll need that session again because we would be copying that certificate over again. But for now, all we need to care about is the integration. So I already have some users created for the Active Directory, and it's really a script that you can run in PowerShell, which creates these users. So there should be about 100 users that I have here in this secure users organization unit, or OU. Okay, so we're gonna import all of these users into our FMC. Let's log in here. Okay, so we'll come into integration, other integrations. And at the top, you have a couple of options here. We already discussed the cloud services part here. Okay, these two things are not going to work for now because they you basically need SecureX for this. Okay, ignore that. This is where you define realms, and this is where you define identity stores. So this is where you would define the ICE integration. Okay, and you do this over PX grid. Okay, so if you have never worked with ICE, obviously a lot of things won't make sense here. Things like MNT or maybe subscribe to, etc. Okay, or SXP. So we'll discuss this when we'll cover ICE. Okay, so let's come back into realms. And we're going to add a new realm. And this is nothing but this is just you giving the details about how the FMC should integrate with Active Directory. Okay, so we just give it a name. And you can do AD, you can do LDAP. You can have or define local user database as well. Okay, we'll do AD. That's our domain. Our user is going to be, it does give you an example of how do you want to put the user and domain, but depending upon how you have configured or maybe how recent your Active Directory server or the Windows server running Active Directory is. So mine is 2019. Okay, so this is the format that it'll. Okay, so if you put in this format, the connection won't establish. Put in the password and just define the base DN here. So all I'll do is I'll just put in my domain here. Okay, same thing. This is going to be 100.50. 636, this is for LDAP secure or LDAP S, okay, which is obviously your secure LDAP. Can do in production, obviously it's much more secure, but in our case, we're just going to do the non-secure version, which is going to be 389, okay? And we're going to use the management interface to establish that connection, okay? Because this is in our management. Look at the topology. So there's our FMC in our management network itself. And we'll just test the connectivity once, just to be sure. And if I change this to maybe secure administrator, which is what it's asking for, or maybe if I just do that, it will show failed connectivity or failed connection. Okay, you could do something like this as well. Okay, that should be good as well. Okay, and we'll click on configure groups and users. It basically is able to pull all the available groups that are present in my on my domain controller. Okay, so all I'm interested in is the users. I'm going to include this. If you want, you can configure your exclusions as well. Okay, so that you don't use any of those ones in your config. Okay, and we'll just do save. Right, so we now have our realm, our integration working. If we come in here to our sync results, we, however, would not see any groups or users. Okay, because we have just done the integration. We also need to initiate a download. Okay, so you can have it set to here. No, not here. Synchronization. Okay, so you can set it to how often do you want the synchronization to happen. Okay, I'll leave it at the default, does not matter. You could change this in production. In our case, what I'll do is I'll come back in here and I'll click on this download button. Okay, are you sure you want to download the users and groups from the Active Directory? Yes, I want to. It adds a task, and then it does not really take too long for it to get the download done. Okay, so let's just give it a couple of seconds, and it was a success. And we can see it was able to download one group and about 103 users. Okay, we can come back into now our sync results, and we should now be able to see a list of our users here that were downloaded. Okay, Adam Wally, Aloma Mar, etc. Okay, so it was able to download all of my users. So now that the Realm integration is done, we can now make use of these within our identity policy. Okay, but before we can do it, we need to work on the certificate part. Okay, so let me first show you the policy here, identity. There are no defaults to this. Okay, add a new policy. And I'll just say captive. Okay. And this way you define your rules and everything. And at the top, you have configuration for active. You need to have a server certificate. It's none. We have created certificates already, but if you're going to see, you won't see them in the list here. Okay, because those are the certificates that cannot be used in captive portal. For captive portal, we need to generate new certificates. Okay, the default is 885. The port number, you can have this, or you can choose a port number between one. So nothing in the well-known port, so nothing from 1 to 1024. Anything above that up until 65535, you can choose any port. Okay. This, again, it depends how much you want to do it. Default is typically good. You give them about 3 chances to do the login. Okay, if you set this to 0, it will be unlimited login attempts. Okay. You do give some sort of a response page. Again, this is for HTTP only. Okay. You might or might not see if, depending upon if it's HTTPS or it's HTML based, you can change it. Okay, your users can change it. Sorry, not the users. The development team and everyone, they can give you a template which you want from, maybe if you want to do some sort of a corporate branding kind of a thing. Okay, not too much that you can do, but still, since it's HTML based, it can still be done. Okay, we'll keep it at the default. And without us doing this, adding certificate and everything, we won't be able to add any rules for active authentication. So let me just come in here, click on add rule. So here you have a couple of options. You can do passive, active, or you can do no authentication. Okay. So within active, you get to choose what you want to do. If you do passive, then you just choose the realm, and then you can basically configure when do you want that authentication to happen. Okay, so let's say when the traffic goes maybe from inside to maybe DMZ, you might want to authenticate users. You might want to see how, who all are the users who are trying to access maybe your DMZ servers and everything, if you have that provision. Wow. Okay. Let's come into object. I'll show you where you would actually do the certificate for this. So on a PKI, we already did here the internal CA. Okay, and you can see this part is basically used in SSL rules to decrypt outgoing traffic. Okay, so certificates present in this section, they really represent an internal CA. Okay, if you come into internal cert, this is where you can have certificates that can be used in SL rules. This will be for inbound. Okay, for ICE connection and for captive portal. Okay, so this is where you would have your certificates for all of these things. If I do an add internal cert, you can only add certificate. There's no option for you to generate a CSR. Okay, and without a certificate signing request, you really cannot have a certificate, basically. Okay, so your CSR is just like an application form. Okay, without filling it, without presenting it to the concerned authority, you cannot get your identity. Okay, so once you have that, this is where goes the certificate. This is where you would have the private key. Okay, and since we cannot do it from here, we need to use an external tool for that. So we have internet working, we should. Okay, so we should be able to download OpenSSL. So I'm going to go to slproweb.com. Okay, so these are the guys, Shine Light Productions, who have this kind of a project, open source project, where you can download the OpenSSL software. Okay, let me come into products, and we're going to look at OpenSSL. Okay, we're going to choose the ESXi file here. 64-bit. Should download pretty quickly. And if you want, you can go through the documentation and everything. I'll show you the commands and everything. Generate the CSR. This is very commonly used in production for the same purpose that we are doing it. Okay, so you can make a note of those commands. It'll be very helpful to run those in if any time you have to do any of that in production. Okay, so we have that. We're going to install it. So there's no web page to this. Okay, you can only run it through the command line. So typically what happens while that finishes, typically what happens when we generate a CSR, when we generate a CSR, it generates that request, okay, which is your subject, which includes your organization name, organization unit, country, the common name, etc. Plus, it also generates a key pair, okay, which is your public key, private key. Private key is kept reserved on the server itself. It's not given out. The public key and this part, this is sent to the CA, okay, to get the certificate. In our case, since we are not doing it on the server itself, we will first after that, we're going to use this private key and we're going to generate a CSR. And then we're going to take the CSR to a CA, get it signed. We are going to then take the certificate and the private key, import it into Firepower. Okay. So let's install this. And you can keep the directory, whatever you like. And I will configure it in the /bin directory. Typically like to do it that way. Software. Okay. And since it's open source, free of cost, they ask for a donation. Okay. We have it installed. We're going to go into command line. And I'll just run it as an administrator just to be safe. Okay. And let me just trying to see if we can increase the size. Font, maybe 20. Okay. So we are in C users. This should be in, so we're going to do a change directory. And this is going to be in program files and OpenSSL. Okay. We are going to go into bin. Okay, we can't run ls from here. This was I've run this from PowerShell. That's fine. We are in here, so we're going to do. So this is where we should have our executable. If you go into C drive, program files, OpenSSL, bin. This is where the executable is, the OpenSSL application. Okay. This is where we are. So what we'll do is we're going to do OpenSSL, generate RSA out, and we're going to generate a key pair, basically private public. We're going to use 2048-bit RSA, okay, to create that. So I'm going to say FTD. Name can be anything, does not matter. Secure.lab.key, just giving it a name, and then 2048 will be the actual bit value. Okay, so it was generated. If you come back in here, we should see that's our key. Okay, that's our key there. Now the next thing is to actually use that key and generate a CSR. So I'm going to say OpenSSL request, and I'm requesting for a new CSR, and we're going to configure key. This would be the hash. I'm going to using SHA-256 key. I'm going to use the same key that we generated. out, and I'm going to say CSR. Okay, just giving it a name. Now it's going to ask us the same things that we configured manually or automatically through the Firepower. We're going to add the country code, state, whatever, city. Okay, organization name. I'm going to just say Secure Lab. Unit, just say Secure Lab. Okay, common name. This is your server FQDN. Okay, so in our case, we're going to just do FTD01 captive. Okay, and just do it that way. Okay. Address, that's fine. Not in production, so we're going to ignore this. You can do that if you want. You can set up a challenge password as well. Not going to do it. Does not, don't really require it. For obviously, these are some of the things that you additionally put in to give you that additional security layer. Okay, you can do that. You can ignore this in here. Don't want to give it any optional company name as well. Okay, so that's fine. We should have our CSR generated here. You can see that. Okay, we have provided all the details. The CSR is there. We have the key. Okay, now you can do a validation for the CSR just to be sure that it was correctly generated. So what I'll do is I'll do OpenSSL request, and we can look at text format, and the input is going to be the CSR, which is ftd.secure.lab.csr. Okay, and I'm going to do a no out. So this is what the data is for the certificate request. Okay, that's our public key. And here is our hash algorithm. So this data and this public key is what will be presented to the CSR. Sorry, the certificate authority. Okay, so that it can sign it. This private key remains private. That's why it's called private. Okay, you don't give that private key out to anyone. Okay, so now what we can do is we can open this in something like Notepad. That's our request. We'll copy this, come into our serve authority, request, advanced, just like we did previously. Okay, use the template web server, submit, and we can download the certificate as base64. Okay, that's our certificate. And we're going to rename this to DD captive. And when we look at this certificate, we can see FTD01 captive.secure.lab. It has been signed by our enterprise CA. If you look at the details, this is the issuer, validity, that's the subject, that's our private key. Okay. So obviously, I mean, you cannot do a match just looking at like that. Okay, but it is going to be same thing. Okay, that's public key. So that's our certificate. So this, along with this key, is what we're going to import into our Firepower. Okay, so let's come in here, add internal cert, call the same name, FTD captive portal certificate, add this cert. And we're going to add that private key. Let's go into our C program files, cell, bin, there's a key. Okay, you cannot just use any key. So if you use anything else, it will fail to download or it will fail to add the license. The key pair. So the public key is in here. The private key is here. Okay, they're a key pair. They were generated at the same time. They both are aware about each other. Okay, so you cannot just use any private key in here. It'll not work. Okay, we have that, and we're now going to do save. So now we have our certificate here. Okay, now this certificate can be used with captive portal. Okay, so when that redirect happens, when this redirect will happen, this user will be presented with that certificate of FTD. And if the user really trusts that certificate, obviously, it'll be transparent. So everything needs to be transparent enough. Okay. So we have that. Now let's come back into our policy, identity, and open this up. Let's first come in here. Let's add our certificate. So the server certificate is going to be the FTD captive portal that we created. We're going to keep everything at the default. Coming into rule, add rule, and let's just say internet access. Okay, so anyone who tries to access the internet, I want to subject them to active authentication. Okay, traffic from inside to outside, traffic originating from this NAT LAN network. Okay, port is fine, but we can still put in HTTP, HTTPS destination. And then we come into this realm and settings. And we're going to choose the realm, which is going to be the Active Directory that we configured. If a user cannot be identified, I want to mark those users as guest. Okay. And there's some options to do different types of authentications. Okay. Now we're going to just use HTTP basic. Check this. And I'm going to say add it. Okay. Obviously, you can further evaluate this. We might change these to a couple of things. We have not brought in our DMZ yet. So after this, we're going to configure and set up our DMZ, see how we can manipulate the DMZ access from the outside and everything. We're going to do some tests. We're going to add a couple of more rules. For now, we're just doing the initial test, making sure certificates and everything are working fine. Okay, save this. Okay, once configured, we have to use it. Go into our access control here to our policy, and this is applied globally. Okay, so we're going to come in here to identity policy. Okay, and save. Okay, so we already have this rule, which is allowing outbound traffic, HTTP. So we are good with that part. Okay, so all we now need to do is we just need to deploy it. And you can see what are changes we have done. Okay, so we added to our existing access control policy, we have added an identity policy. And we have made a bunch of changes to our identity policy here. And we have also added a bunch of objects. Okay. This out, deploy. There is one additional change that we still would need to do in order to allow that captive traffic, but I've not added that because I want to show you how it will look like in the logs. Okay, so I'll exit out of this. Don't need that anymore. We already added the root CA certificate, so we should not need anything additional. Okay, should be able to test it from here. Let's close this out. Let's have a brand new session once it logs in. Okay. Let's come in here. Let's try to access any website. Let's just do tube. It might be working because of cache. Let's just try a different website. Let's just do Reddit. Okay, that's working as well. Let's just check the policy. Not the policy, the events. It's okay. 101. Reddit. Okay, allowed. Reddit. Okay, let's recheck policy because it did not trigger the captive portal. So we have the identity policy configured. Traffic. There's nothing else in here. From identity perspective, it's updated. Inside to outside, it's network. Fine. Session port, it's random active authentication and HTTP basic. Have the port and everything. That is fine. Config looks okay. You can ignore these. This is the DMZ server. Okay, the 172.16, 150.100, so we ignore that. Okay. Let's try with a different browser once. Let's do com. Okay, so let's push this. Now we can see a couple of things. Look at the port. Okay, so it's trying to connect to website, but it's being redirected on the FTD itself, and the redirect is happening port 885, it's TCP. Okay, but the traffic is not being allowed. So that's why you don't see that redirect happening there. Okay, so it just times out. If we filter it out based on that port, okay, so we can see all of those blocks. And if you come to the right, we can see default action. That is blocking that traffic. Okay, so if we go back into our policy, none of our rules are actually allowing any traffic to TCP port 885. Okay, and obviously we have a default action configured here for block all traffic. And another interesting thing was that for this, you only see the ingress zone. You don't see the egress because we are not going out of the firewall yet. Okay, the traffic is just being redirected to a different port on the firewall itself, on this inside interface. Okay, which is facing the LAN or the users. Okay, so you're not going to see any egress here. Okay, so obviously we need to accommodate for that in our policy. So I'm going to add a rule, and I'll just do trust. Okay, so I'm going to say traffic originating from inside. Obviously, there's no outside zone. This. From a network perspective, we're going to say it is originating on our LAN, and destination is obviously 10.0.1110.1. Okay, port TCP, I'm going to do 885, and log this just in case. Put this out top here. Okay, save this. Now, we have to put in a rule for everything because our default action is set to deny all. Okay, a lot of times production environments do allow this to be set to something else, which still allows the traffic to flow through the firewall, get inspected, okay, but does not do a deny. Here, since we're denying everything, anything that we want to allow access to the firewall through the firewall, we really have to do this. Okay, for everything. For example, we had to do this for our RDP. We have to do this for captive as well. Let's deploy this real quick and then test it once again. So if sometimes the captive is not working, for example, like it was not working with the Chrome, it typically is because of the websites and everything that have been cached already. Okay, so the browser just uses that. Okay, and captive does not work. So just try it with a different browser. So if your configuration and everything is correct, if you change the browser, things should work fine. Okay, that is good. Let's come back in here, and you can see that it did actually show the URL where it's being redirected to. Let's come back and let's do the same thing. Okay, so we actually get non-secure because we have not added that new certificate that we created, but you get the idea. Okay, you need to have all of those certificates in the trusted store. Okay, but now we can see the redirect happens. If we continue this, it should pop us to do the authentication. Okay, so we need to put in a username and password. So what we'll do is I'm gonna pull up a username, and I can use Adam.Wally, or maybe I'll use a different one. Let's just see. Let's use anything. Let's just use Ivan Davy. I'll just reset the password because I don't remember the password. Okay. So we can log in as Ivan.Davy. That's the logon name. Okay, and the password that we just configured. That password. Okay, and the traffic is allowed to go through. Okay, let's look at the logs here. You can see this traffic here. Let's come here. Where is Cisco? Cisco. There it is. Okay, so the traffic was allowed to go through. Now we can check the user details as well. We are looking at that user awareness part, what all we have captured for that user. So if you come into analysis, you have the user tag here, okay? And I can look at my users here, who all are accessing my network. And we can see that we have captured a bunch of different things. The user, when was he last seen, realm, the username, his first and last name, the email address, what department does he belong to, his phone number, etc., etc. So all of these details are present within the Active Directory. Okay, and since we have that integration and everything, we are able to pull that information. Okay, come into users, and probably you're going to see the same thing. Okay, user identity. Okay, so that's the user awareness part. Okay, so your integration with Active Directory gives the user awareness part. You're able to capture the user identity, and then that can be used for something like active authentication, like we saw with a captive portal. One of the things, if you would have noticed, when it did the captive portal, it actually showed us an IP address. Okay, it showed us an IP address for the FTD, right? It showed us something like this. Okay, you cannot change it for now. We are on 705. I think Cisco added the option to use FQDN, which is obviously a much more or a much better way to do it, right? So you could do something like captive and your domain. Okay, rather than using an IP address for your firewall, right? So I think they added this with 7.1. Okay, and you do get an option with 7.1 for that. I think so. Anytime you have to verify anything, just look at the release notes for that particular version. That should show you what are the new features that were introduced. Okay. So let's just come down to routing, policy, VPN, intrusion detection, identity services. There it is. Support for host name based redirect. Okay, so now you can redirect the user's authentication to an FQDN rather than an IP address of the interface through which the user connection enters the device. Okay, so they have added a redirect to host name option in the identity policy settings. Okay, so with 7.1, you or the users can really hide it, make it a bit more cleaner, much more transparent for the users. Okay, that's our identity policy. And that's how you do certificates. That's how you make use of OpenSSL. Okay, if you ever have to use it for anything, okay, it's a very versatile tool. It's a very useful tool for production. Okay, and that's how you do two different types of certificates that we have seen. If you do want to add and do the inbound traffic decryption, this is the same way that you would import the certificate from a web server to which the traffic is destined, to which you are trying to do the inspection, do the decryption of the traffic. Okay. And one more thing in addition to this, after this, we'll take a quick break. You remember we were doing network discovery. We enabled network discovery, and we have been seeing a lot of traffic from, we have been using this user. So we should have some substantial things that we can now see from the network discovery as well. And since in our topology, our user here is just one hop away from the firewall, and I told you that the closer the firewall is to the users or to your LAN network, the much better and with much more accuracy and confidence, the firewall will be able to determine the contents of the or the host profile, basically, specifically the operating system. So let's come into analysis and hosts, and we're going to come into hosts here. And we will be visiting this a couple of times later on, okay? So you can see a lot of things have been identified by the firewall, okay? Some operating systems it has identified, some Microsoft devices it has identified. For some of them, it's showing as pending, okay? Let's come into network map. This is where you actually see the host profile database, okay? So you can see it has identified two networks. One is 10.0.1.10.101, which is your LAN. And we also have 172.16.150.100. This is a DMZ. Okay, so I did provision this server over the week. Okay, so there's nothing really, just give it an IP address, enable IIS service, and that's about it. Okay, so we do have that. And we did not have any policy that's allowing traffic from this. That's why you saw a lot of blocks happening for this network, okay? So let's just view the profile for this LAN user, which is what we have been using in our testing. Okay, it's the IP address. It says how many hops away is the firewall, or is the user or the client from the firewall. It's 1 hop away. Okay. This is the current user on that machine. Okay, so we have that user identity. From the perspective of systems, the operating system is one of these. Now, you're going to see this a lot. Okay, and the reason for this is depending upon the TCP IP stack that is being used on the operating system. So Windows 10 operating system TCP IP stack would be similar to what it was on Server 2012 to what it was on Windows 8.1. Okay, so that's why you might see multiple operating systems being mentioned, because the TCP IP stack is really the same. Okay. You can see what all application protocols have been used. So we have used Chrome. You see the version as well. Okay. We have used Edge. DNS has been used. RDP has been used. Okay. Now, how does this help? Maybe we are not allowing RDP on our network at all. If one of my users, I've seen them use RDP, this might call for further investigation. Okay, and I can see who was the user. Okay, so it gives me a little bit more evidence. Okay, so in my next meeting, I'll probably be calling that guy and asking him details about why and what for was RDP used. Right, similarly to the other things here. You can see the user history. Okay, and we see host protocols at the bottom, what were used: ICMP, TCP, UDP, IP, obviously. Okay, if you see some bizarre protocol here, which is not really used in your network or in your infrastructure, that could be kind of like a red flag as well. Okay, and at the bottom, you see vulnerabilities. Okay, now these vulnerabilities are really dependent upon what operating system it has figured out and the different versions of these application clients and everything. So it might be that on Windows 10, this particular Chrome version has some vulnerabilities. Okay, so it would have highlighted this. So what the firewall is doing, it is comparing this host profile data against the VDB database, which has the vulnerabilities. And when it finds a match, it basically highlights it here. Okay, and you can check the details for any of the vulnerability if you want. Okay, it is going to show you the CVE ID, the description. What is the impact? What is the severity? Base score 9.8, which is critical. To be honest, high to critical. Okay, so you can see a lot of the information from here. Okay, it obviously does not fix them. Obviously, it's a firewall. It's giving you visibility. Okay, it's your job really to fix those, patch your devices. Okay, so it's not a patching system. It's really giving you the details about all of those vulnerabilities. Okay, you do see SNOT ID and SVID. We're going to cover this when we talk about IPS. Okay, but you get to view a lot of good information. Okay, so you can really go ahead, copy this, open up something like NVD, which is the database. Okay, you can look at MITRE Corporation. You can see the details about that vulnerability. Okay, you can look at NVD, which is USA is basically it is a NIST database which handles the database for all the vulnerabilities. So you can see more details about that CV, what it was, when it came out, etc., etc. I mean, it's obviously evident it came out in 2019. You get some details. Okay, it's critical. It's a critical vulnerability. Okay, and it affects Windows 10 and Windows 10 servers. I mean, obviously Windows 10 servers, it's really going to be either of those Windows servers. Okay, we will come back to this tab later on when we'll do some more malware-based testing and everything. Okay, we will be able to see other events. Okay, and from here you can see other events for this PC. Connection events, you can see intrusions, file events, malware events for this particular client. Okay, and this user awareness part really helps to link who was present on the machine at what time, what incident happened on our network, etc. Okay, any question? Okay, right, let's take a 15-minute break. Okay, let's meet back at 1:25, then we continue with this. Okay.